We're going to try to make a very fast structural equation modeling video that will test a theory. Okay, so our practice one here is, does attitude and preparedness predict how well a student will do in advanced statistics? And our three constructs are attitude towards learning resources, and here's all the little subscales. Preparedness, in other words, how ready they are for advanced statistics, and here's their subscales. And competency, this is like our DV. In this case, it's our endogenous variable, competency. So first step is we're going to look at the actual model. There it is. So we're going to reconstruct this using Amos and go through the many different steps to run a structural equation modeling. So let's get started. All right, like every other test known to man, you're going to check the assumptions, okay? So, and there's a lot of assumptions for this SEM, but we're strictly going to look at right now multivariate normality, multicollinearity, and of course, sample size. So here's the data sheet that goes with the SEM. Everything's been preset. We also collected ID number and age. Multivariate normality. Okay, to do that, we're gonna fake out SPSS. We're gonna go to Analyze, Regression, Linear. We're gonna pick a dummy DV. That's our ID number. Boom, and we're gonna stick all our measured variables in as independent variables. We're going to look at the Mahalanobis. Okay, so we really don't need any of this. Don't need the estimates. Don't need Durbin-Watson. We strictly, basically, just need the Mahalanobis. Okay. Again, we're using a trick in SPSS that will identify any possible outliers. Click Continue. Click OK. Here's the output. Let me straighten it out for you. Okay, so remember, don't put age in there, but all the rest of the measured variables put in there. So we're going to scroll down. We don't care about any of this information. The only thing we want is the maximum Mahalanobis distance, and it's right there. Let me pull this up a bit. Hold on. And there it is. So according to this, our data has a Mahalanobis distance statistic of 66. That is a possible outlier. So that's the cutoff. So let's go ahead and check our Mahalanobis distance calculator to see what the critical Mahalanobis distance is. So please hold while we pull this up. Okay, so we need the sample size. It's 400. And how many IVs we have? We have 4 plus 4 plus 5 is 13. Okay, so here is our Mahalanobis critical value sheet. Sample size is 400. K is the number of variables, and we got 13. Click OK. Okay, so our critical Mahalanobis is 40.2. So let's go back to our data sheet. We're going to scroll over to the Mahalanobis. There it is right there. So here's our Mahalanobis distances. We're going to right-click. We're going to put them in descending order. And so anything over 40.2 is considered an outlier. So it looks like 1, 2, 3, 4, 5 of them. So we're going to get rid of these 5. Hold on. All right, we're just going to delete them. So delete 1, delete 2, 3, 4, 5. Okay, so now our data is free of outliers. So let's get going. Now we're going to check the assumption of multicollinearity. Again, we're going to trick SPSS by going to Analyze, Regression, Linear. We simply use the ID number as the DV. We use all our measured variables, those are the rectangles in the box, as our IVs, and then we're going to just, all we want is the collinearity diagnostic, right? That's going to be our BIF or our tolerance. So let's click that, click OK. And let's pull up the output for, again, we're just looking at the tolerance in BIF. Okay, so if the tolerance is less than 0.1, you're in trouble. Greater than 10, you're in trouble. Don't see any problems with multicollinearity. So that's number 2. We've covered multicollinearity and multivariate normality. Last thing is sample size. Sample size, we're just going to use the rule of thumb of 20 subjects per item. So flipping back to the big picture, each box is an item. So it's a measured variable. So there's 1, 2, 3, 4, 5, plus 4 is 9, plus 4 is 13. So 13 times 20 is 260. We have 400, so therefore sample size is not going to be an issue. So those three assumptions have been taken care of. Onward and upward. We forgot to mention that we do have a free SEM sample size calculator online. It is in the Moodle. Go ahead and click this link and fill in the data. It will give you a minimum number. So if you want to do that, that's fine. Okay, there is one more assumption that we're going to check at a later time. We're going to run an exploratory factor analysis. That is when we're going to check this positive definiteness. I can't even pronounce that. But what this basically does is it makes sure that your matrix, the determinant of your matrix, is not zero. If your matrix determinant is zero, that means that there's something wrong with the matrix, and you can't use this. So that's just going to be a farther down the road check. So, but we will get to it here when time comes.